Good morning, students. Previous class we have discussed about the reduction formulae, and let us continue the problems based on the reduction formula in this video. So, reduction formula for integral secant power nx dx for an integer and greater or equals to 2 and hence reduce integral secant power 5x dx. So, first of all, let this integral secant power nx dx, we'll take it as in. So this secant power nx is written as secant power n minus 2x into secant square x dx. So this is equals to, this is first function, this is the product of two functions. So we have integration by parts. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to secant power n minus 2x integral secant square x dx is tan x minus this is d by dx of secant power n minus 2x. So this can be taken as d by dx of secant x whole power n minus 2. So let us take secant x to be x. So x power n minus 2 is n minus 2 into x power n minus 2 minus 1. So n minus 3. So this power will come forward into secant power n minus 2 minus 1 n minus 3x into, since secant x is treated as x, so let us differentiate it later, which we have discussed in the chapter of differentiation last year, into d by dx of secant x into integral secant square x dx is tan x. So the bracket closed dx. Integral secant square x dx is tan x, bracket closed dx. So this is equals to secant power n minus 2x into tan x minus, since n minus 2 is constant, let us separate it from the process of integration. So n minus 2 integral of secant power n minus 3x into d by dx of secant x is secant x into tan x into tan x. Tan x is already there, so tan x into tan x is tan square x dx. So this is equals to secant power n minus 2x into tan x minus of n minus 2 integral secant power n minus 3x into secant x is secant power n minus 2x into, this is tan square x. We know secant square x minus tan square x is 1. So secant square x minus 1 is tan square x. So this tan square x can be written as secant square x minus 1 dx. So this is equals to secant power n minus 2x into tan x minus of n minus 2. So this is secant power n minus 2x into secant square x. So bases are equal. N minus 2 plus 2 is secant power nx minus secant power n minus 2x into 1 is secant power n minus 2x dx. So this is equals to secant power n minus 2x into tan x minus n minus 2 is multiplying with both of these. So integral dx is also to be distributed for both of them. So this is n minus 2 integral secant power nx dx minus into minus plus n minus 2 integral secant power n minus 2x dx. So this is what we have got so far. So this is equals to secant power n minus 2x into tan x minus n minus 2 integral secant power nx dx. We have taken it to be in earlier. So I am replacing integral secant power nx dx to be in plus this is n minus 2. If integral secant power nx dx is treated to be in, so integral secant power n minus 2x dx can be written as in minus 2. So this is all in. So in, this minus of n minus 2 in, let us take this to RHS. This is plus n minus 2 in is equals to secant power n minus 2x into tan x minus plus n minus 2 in minus 2. So let us take in as common. So this is 1 plus n minus 2. This is equals to secant power n minus 2x into tan x plus n minus 2 in minus 2. So this is minus 2 plus 1 is minus 1. So n minus 1 this is. Therefore, in is equals to, this is n minus 1 is multiplying with in. So if you transpose onto another side, it will be dividing with both of them. So secant power n minus 2x into tan x by n minus 1 plus n minus 2 by n minus 1 in minus 2, where n is greater than or equals to 2. So this is the reduction formula for integral secant power nx dx. So hence it has asked the question to evaluate integral secant power 5x dx. So let us evaluate it. Integral secant power 5x dx. So this is written to be I5. So this 5 is greater than 2. Therefore, the reduction formula, whichever we have got here, can be used. So this is secant power 5 minus 2 is 3x into tan x by 5 minus 1 is 4 plus n value is 5. So 5 minus 2 is 3 by 5 minus 1 is 4 I 5 minus 2 is 3. So now 3 is still greater than 2. So therefore this reduction formula which we have deduced so far is also applicable. So this is secant cube x into tan x by 4 plus 3 by 4 into n value is 3. So let us substitute 3 here. In the place of n, 3 substitute. 3 minus 2. 3 minus 2 is 1. So secant x into tan x by 3 minus 1 is 2 plus 3 minus 2 is 1 by 3 minus 1 is 2 I 3 minus 2 is 1. So this is equals to secant cube x into tan x by 4 plus 4 2s are 8. So 3 by 8 secant x into tan x plus 3 by 4 into 1 by 2 is 3 by 2 I1. So this 1 is not equals to, is not greater than 2. Therefore the reduction formula cannot be applicable. So let us substitute I1 in the original one. So this is in is equals to integral secant power nx dx, right? So now I1 is equals to integral of secant power 1x dx. So this is secant power 1x dx is secant x. Integral secant x is log mod secant x plus tan x. So this I1 let us write here. Therefore, integral secant power 5x dx is equals to secant cube x into tan x by 4 plus 3 by 8 secant x into tan x plus 3 by 8 log mod secant x plus tan x plus constant of integration c. Reduction formula for integral sin power mx into cos power nx dx for a positive integer m and an integer n greater or equals to 2. So first let us take this integral sin power mx into cos power nx dx to be I mn, because this integrand is comprising of both the power m and power n, so I mn. So let us write this sin power mx into cos power n to be cos power n minus 1x into cos x dx. So since bases are equal, so n minus 1 plus 1 is n. So let us take this to be the first function and the remaining to be the second function. So again by parts, product of two functions. This itself is one function and the remaining sin power mx into cos x to be the second function g of x. So first function into integral of second function sin power mx into cos x dx minus integral of d by dx of first function is integral is cos power n minus 1x d by dx of first function into integral of second function sin power mx into cos x dx whole dx. So this is cos power n minus 1x. Now integral sin power mx into cos x dx. So this is of the form f of x whole power n into f dash x. Sin x derivative is cos x. Sin x derivative is cos x. So sin x is f of x. F of x whole power m into sin x derivative f dash x is this. So f of x whole power m into f dash x dx. We have the result f of x whole power m plus 1 by m plus 1. So f of x is sin here. So sin power m plus 1x by m plus 1. So if you do not understand this, no problem. Let sin x is equals to t. So sin x derivative is cos x dx is equals to dt. So integral of sin is t. So t sin power mx means sin x whole power m. So sin x is t. So t power n into cos x dx is dt. So integral t power m dt is t power m plus 1 by m plus 1, where t is sin x. So this is sin x whole power m plus 1 by m plus 1 or sin power m plus 1x by m plus 1 minus integral of, so d by dx of cos power n minus 1x. So this is nothing but d by dx of cos x whole power n minus 1. So let us take cos x to be x. So x power n minus 1. d by dx of x power n minus 1 is n minus 1 into x power n minus 1 minus 1. d by dx of x power n is n into x power n minus 1. So d by dx of x power n minus 1 is n minus 1 will come forward into cos power n minus 1 minus 1 is n minus 2x into, since cos x is treated to be x, then it has become x power n minus 1. Then we have got a formula. Since cos x is treated to be x, d by dx of cos x is minus sin x. d by dx of cos x. Since cos x we have treated it to be x, then it has become x power n minus 1. Then we have got a formula and we have applied it. Since cos x we have treated it to be x, therefore we have to differentiate it later. d by dx of cos x is minus sin x into integral sin power mx into cos x dx. This is the same. So sin power m plus 1x by m plus 1. Sin power m plus 1x by m plus 1 whole dx. So this is equals to cos power n minus 1x into sin power m plus 1x by m plus 1 minus n minus 1 by m plus 1. These two are constants. So I have separated them from the process of integration. Minus into minus is plus. Integral of cos power n minus 2x into, this is sin x into sin power m plus 1x. This is sin x into sin power m plus 1x. Sin x means sin power 1x. So bases are equal, exponents are to be added, m plus 1 plus 1. So sin power m plus 2x dx. So this is equals to cos power n minus 1x into sin power m plus 1x by m plus 1 plus n minus 1 by m plus 1. So this is integral of cos power n minus 2x. So sin power m plus 2x can be written as sin power mx into sin square x. Sin power mx into sin square x dx. And this sin square x can be replaced as 1 minus cos square x dx. Again, cos power n minus 2x, sin power m plus 2x can be written as sin power mx into sin square x. So bases are equal, exponents are to be added m plus 2. So we got. So this sin square x I have written to be 1 minus cos square x. So this is equals to cos power n minus 1 x into sin power m plus 1 x by m plus 1 plus n minus 1 by m plus 1. This is integral cos power n minus 2x into sin power mx into 1 is cos power n minus 2x into sin power mx minus cos power n minus 2x into sin power mx into cos square x. So cos power n minus 2x plus 2 bases are equal. So we got it to be cos power n minus 2 plus 2 is cos power nx into sin power mx whole dx. Again, integral cos power n minus 2x into sin power mx into 1 is itself minus this into cos square x. So cos power n minus 2x into cos square x. Bases are equal. N minus 2 plus 2 is cos power nx into sin power mx dx. So this is what we have obtained so far. Cos power n minus 1x into sin power m plus 1x by m plus 1 plus this n minus 1 by m plus 1 is being multiplied with both of them. So integral dx is to be distributed for both of them. So n minus 1 by m plus 1 integral of cos power n minus 2x into sin power mx dx plus into minus minus n minus 1 by m plus 1 integral sin power mx into cos power nx dx. So this is Imn. So let us transpose this minus of n minus 1 by. So this is equals to cos power n minus 1x into sin power m plus 1x by m plus 1 my plus n minus 1 by m plus 1. So this can be written as I m comma n minus 2. Since integral sin power mx into cos power nx dx is treated to be I mn, so this is I m comma n minus 2 minus of n minus 1 by m plus 1 I mn. So this we have treated to be I mn earlier. So soon after started this solution, so this we have treated to be I mn. Now let us transpose this minus of n minus 1 by m plus 1 I mn onto the other side. So this is I mn plus this is n minus 1 by m plus 1 imn is equals to cos power n minus 1x into sin power m plus 1x by n plus 1 plus n minus 1 by m plus 1 I m n minus 2. So let us take I mn as common, then its quotient is 1 plus n minus 1 by m plus 1 is equals to cos power n minus 1x into sin power m plus 1x by m plus 1 plus n minus 1 by m plus 1 I m n minus 2. So this is I mn, this is m plus 1 plus n minus 1 by m plus 1 is equals to cos power n minus 1x into sin power m plus 1x by m plus 1 plus n minus 1 by m plus 1 I m n minus 2. So this plus 1 and minus 1 gets cancelled. Therefore, this is I mn into m plus n by m plus 1. So, since this is m plus n by m plus 1 is multiplying with this, so if you transpose onto another side, it will be reversed. So m plus 1 by m plus n. So that m plus 1 by m plus n, let us multiply with both of them and see what will happen. Therefore, I mn is equals to cos power n minus 1x into sin power n plus 1 x by m plus 1 into, this is m plus n by m plus 1. If you take to the side, so it will multiply with both of them. So this is m plus 1 by m plus n plus this is n minus 1 by m plus 1 into I m n minus 2 into this is m plus 1 by m plus n. So this m plus 1 gets cancelled, this m plus 1 gets cancelled. Therefore, I mn is equals to cos power n minus 1x into sin power m plus 1x by m plus n plus n minus 1 by m plus n I m n minus 2. So this is the reduction formula for integral sin power mx into cos power nx dx. Now let us start the exercise 6f based on this reduction formula. So very first question is integral e power x into 1 plus x square dx. So this is equals to, so e power x into 1 is e power x dx plus this is x square into e power x dx. So this is the form integral x power n into e power ax dx. So this reduction formula already we have done in the previous video. So we have integral of x power n into e power ax dx is equals to x power n into e power ax by a minus n by a I n minus 1. Now let us do this. So this is integral e power x dx is e power x plus, so here x square into, so here n is equals to 2 here, so x square into e power ax means 1x, so this is x only, by a is x quotient, so that is 1 minus n by a, so n here is 2, here n is equals to 2 and a is equals to x coefficient 1. So x power n is x square into e power ax, e power 1x. So x by a is 1 minus n by a. N is 2 by a is 1. I n minus 1. N here is 2. 2 minus 1 is I1. E power x plus x square e power x minus 2 by 1 is 2. I1 x power 1 into e power ax. So 1x. That is x e power x integral dx. So this is equals to e power x plus x square e power x minus 2 x e power x. So this is product of two functions. Highlight is used. So this is algebraic, this is exponential function. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So 2 is being multiplied with this whole. So this is e power x plus x square e power x minus 2 x integral e power x dx is e power x minus d by dx of x is 1. Integral e power x dx is e power x. This is dx, bracket close. So this is e power x plus x square e power x minus 2 x e power x. So minus into minus plus 2 into integral 1 into e power x is e power x. Integral e power x dx is e power x plus constant of integration c. So this is equals to this is e power x plus 2 e power x is 3 e power x plus x square e power x minus 2x e power x plus c. So take e power x as a common, then x square minus 2x plus 3 plus constant of integration c. Integral x power n into e power ax dx is equals to x power n into e power ax by a minus n by a I n minus 1. So here in the place of n you may see 2 and a is equals to minus 3. So let us substitute in here. So integral x square into e power minus 3x dx is equals to, so x power n value is 2 into e power minus 3x by the value of a is minus 3 minus n by a, n value is 2 by a value is minus 3. I n minus 1, 2 minus 1, so 1. So this is equals to x square into e power minus 3x by minus 3. So this is plus 2 by 3 I1. So I1 means substituting n equals to 1 here. Integral x power 1 into e power minus 3x dx. Since 1 is less than 2, as far as n greater or equals to 2, we will substitute in this reduction formula. Since 1 is less than 2, which is not this is valid as long as n greater or equals to 2. Since 1 is less than 2, since it doesn't hold this inequality, so we are not going to use substitute n equals to 1 here. So directly in the given equation we will substitute. So this is equals to x square into e power minus 3x by minus 3 plus 2 by 3. So this is product of two functions. So by parts method is used. So this is first function into integral of second function dx minus integral of d by dx of first function into integral second function dx whole dx. So this is equals to x square into e power minus 3x by minus 3 plus 2 by 3 into x. Integral e power x dx is e power x. So e power minus 3x by its quotient d by dx of minus 3x is minus 3 minus. So integral of d by dx of x is 1 into integral e power minus 3x is e power minus 3x by minus 3. Integral e power minus 3x is e power minus 3x by minus 3 dx. So this is equals to x square into e power minus 3x by minus 3. So plus into minus 2 by 3 3s are 9 x e power minus 3x. So here minus gets cancelled here. So this is plus 2 by 3 3s are 9 e power minus 3x. Integral e power minus 3x is e power minus 3x by minus 3. So this is e power minus 3x by minus 3. So 9 into minus 3 is minus 27 plus constant of integration c. So this is equals to, the LCM is 3 9 27. 27 is the LCM. So by 27. So minus e power minus 3x. Let us take minus e power minus 3x as common. Then we will get, so 27 by 3 is 9. So 9 into x square, 9x square. So since minus is taken common, so minus e power minus 3x is taken common. So 27 by 9 is 3. 3 into 2 is 6. So 6 into x, 6x. Next, 27 by 27 gets cancelled. E power minus 3x is already taken common. So this is already minus is taken common. So this is plus 2 plus constant of integration c. Integral x cube into e power x dx. So we have integral x power n into e power ax dx is equals to x power n into e power ax by a minus n by a I n minus 1. So this is the reduction formula for x power n into e power ax dx. Here n is equals to 3. So this is x cube into e power ax dx is equals to, so x cube into e power ax by a, because a is unchanged, so this is same. So in the place of n we'll take 3 minus n by a. N is 3, so 3 by a I 3 minus 1 is 2. So this is x cube into e power ax by a minus 3 by a into I2. So this still valid because this reduction formula is n greater or equals to 2. As long as it holds this inequality, we will use this reduction formula. So now in the place of n, 2 can be substituted here. So x square e power ax by a minus n by a. N value is 2. So 2 by a I 2 minus 1 is 1. So this is equals to x cube e power ax by a minus 3 by a into a is a square into x square e power ax minus into minus plus 3 2s are 6 by a square into I1. So we cannot use n equals to 1 in this because this reduction formula is valid as long as n greater or equals to 2. So 1 is less than 2. So let us directly substitute here. So integral n value is 1 here. So x power 1 is x into e power ax dx. So this is equals to x cube into e power ax by a minus 3 by a square x square e power ax plus 6 by a square into, this is again product of two functions. So by parts method is used here. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So bracket off. So this is x cube e power ax by a minus 3 by a square x square e power ax plus 6 by a square x into integral e power x dx is e power ax by a minus integral of d by dx of x is 1. Integral e power ax dx is e power ax by a. Integral e power x dx is e power ax by a dx. Bracket off. So this is x cube e power ax by a minus 3 by a square x square e power ax plus 6 by a square into a is a cube x into e power ax plus into minus is minus 6 by a square into a 6 by a cube into integral e power ax dx is e power ax by a. So e power ax by a plus constant of integration c. So this is what we have obtained so far. This is x cube e power ax by a minus 3 by a square x square e power ax plus 6 by a cube into x e power ax minus a cube into a is a power 4, 6 by a power 4 into e power ax plus c. Now, so a square, a cube, a power 4. The LCM is a power 4 and in everything e power ax is to be common. So let us take e power ax to be common in each term by a power 4 is the LCM. Then we'll get a power 4 by a is a cube. So a cube into x cube. Since e power ax is already taken common, minus a power 4 by a square is a square. So a square into 3x square. So 3a square x square plus a power 4 by a cube is a into 6 into x. 6ax minus. So a power 4 by a power 4 gets cancelled. So 6 plus constant of integration c.